So, what is a pod, and what are its features? Let me try and explain. Every pod has its own unique cluster IP address. All of the containers inside that pod share the same IP address. They also share the pod's hostname, network interfaces, and ports. This means that the pod's containers must coordinate together to avoid using the same port. From a networking perspective, it's as if containers are all running on the same logical host. Every container has its own isolated file system. Containers cannot access files in other containers. But containers in the same pod can share storage using a Kubernetes volume. When a volume exists, it's attached to a pod. You'll learn all about this in the chapter on volumes. A pod's containers are always deployed together onto exactly one node. A pod's containers will never be split up and deployed onto different nodes. All pods in a Kubernetes cluster live in a flat network address space. This means that containers in one pod can communicate with containers in another pod without the help of network address translation. It's as if the pods are all computers which live on the same local area network. In other words, communication between pods is hassle-free, something that isn't always the case with other container orchestration solutions. All of the containers in a pod share the same IP address. They can communicate with each other via localhost or 127.0.0.1. They can also communicate with each other using IPC channels like pipes, Unix domain sockets, and so forth. This is another way in which containers in the same pod act like they're on the same logical host machine. Replication is the term used in the Kubernetes world to refer to horizontal scaling. This is where you run additional copies of the component which you want to scale out. For example, let's say that you manage an e-commerce website which is under considerable strain thanks to large holiday crowds. You know, one of those good news, bad news kind of situations. Anyway, you need to replicate your web server container to handle the heavy load. But here's the catch. You can't replicate containers directly in Kubernetes. In other words, you can't create additional containers in a pod. What Kubernetes does is replicate the pod. You see, when you create a new pod replica, Kubernetes automatically duplicates all of the containers in the pod. That's a pretty handy feature. Pods are ephemeral objects, i.e., they're not durable. This means that when a pod dies, it's dead and doesn't resurrect on its own. A pod can die or disappear for a number of reasons. Perhaps the node it's on fails. Or perhaps Kubernetes is in the process of scheduling the pod to a node and the scheduling operation fails. Pods can be convicted. You're guilty. Pods can be evicted when the node they're on runs out of resources. Pods can also be evicted when the node they're on undergoes maintenance. Pods don't have the ability to self-heal. That means that when a pod goes down, it stays down. The self-healing capability, which I touted to you at the beginning of this course, is actually provided by another kind of Kubernetes component called a controller. We'll go over those more later. Once you learn to use Kubernetes, you need to get a feel for designing clusters. One of the first skills that you need to master is the ability to determine when a container should be in its own pod or when multiple containers should live in a single pod. In this section, I'm going to try and convey to you some general principles for making these kinds of decisions. In general, most pods will only have one container. Now, you might be worried that this is inefficient, but it's not. Pods are lightweight, so don't try and stuff them full of containers in the name of efficiency. When should you put multiple containers in a single pod? Well, put multiple containers in the same pod if those containers are tightly coupled. Determining if two containers are tightly coupled is a bit of a judgment call. I consider containers to be tightly coupled if they work together and if they should be replicated at the same time. For instance, let's say that you have a server container and a DB container. The server is used a lot, whereas the DB is only used a little. To meet increasing demand, you'll need to replicate the server sooner than the DB. Thus, they're not really tightly coupled and should live in separate pods.